Okay. So in this particular section, we are focusing on being able to interpret information given as a graph, as a table, and to be able to produce a graph or to make a graph to model a situation. So the first example that they have for us here, it wants us to tell which table best corresponds to the given situation. So it says Mr. Savoy begins the math lessons by going over yesterday's homework assignment. The class discussion about the new topic is lengthy. So the new topic is the lengthy topic. The remaining class time is spent in group work. So the first thing that I look at is the time frame that it gives us is the lengthy. So the new topic seems to be the longest. The only one with a long new topic was the first one. It also said like the remaining class time is spent in group work. So it didn't make it sound like these were equal either. And so you just kind of pick apart things that you can and cannot rule out. So the review was the same in all of them, but the new topic was not. And that is the one that they gave us the most information on. So we are able to kind of eliminate these two and go with table 2 for our answer. So this basically just wants you to read the information and pick out the other stuff that can pinpoint which one goes with it. So again, on the next one, and the reason why I have some of this filled out is because, like I said, I started making a video and then I had to redo it. So at home today, Tim spent 2 hours on his schoolwork. He had no science homework today. His French assignment was to go over the errors made on yesterday's test. So no science. Tim had only one, and one thing that you can do is kind of like do some highlighting and underlining during this. So there was no science. His French homework was to go over. He only had one minor error. So there was a minor error on his French test, so that's not very much. Tomorrow was a math quiz. He's confident about math, so that means that he's probably feeling pretty good. He does need to do some research for his civics report. Now, research is generally something that takes longer. So we can go through this. No table can be eliminated based on his science time, since it's 0 minutes, okay? The French review should not have taken very long, so eliminate table 1. They had 60 minutes for the French review, and that's not what he needed to do. The other two have 5. Given the circumstance, Tim would have spent more time on civics than on math because he was researching, okay? So the table that best corresponds is table 3. You know, they have math here is 100 and math here is 30. They kind of flip-flopped them. So that's how I was able to choose table 3. So it's kind of just weeding out information and deciding which goes with which. Now, the next type of problem, they want you to read the situation and match it to the graph. And I've kind of spoiled this for us. One thing is important to do is read your access labels. They're all the same in this problem. And this is capacity and time. So it's talking about a bathtub, okay? It starts off at 0 on all of them. So that's one important thing to note is where does it start? So James is gonna take a bath. After letting only hot water into the tub, he turns off the faucet while he is shaving. So that means for a little bit of time that the water level doesn't increase or decrease. So it fills up and then it pauses. Fills up and then it pauses. This one, it fills up and then it fills up really fast and then it pauses. So right away, we can kind of rule out graph 3 just mentally. So then it says he shaves, so that's time that goes by. Then he adds warm water until the tub is 3/4 full. He takes a bath and then empties it. So if you were following graph 1, he shaves, fills the tub, and then he would just empty it all right away. But that didn't happen. He filled it up, shaved, filled it up the rest of the way, then he sat in the tub for a while so the level stayed the same, and then he emptied the tub. So that's how we know that graph 2 is a correct graph, okay? So my last couple examples, similar situation. This one talks about a car on a dino coaster ride for children, climbs the top of a hill. At the top of the hill, it slows down and comes to a stop. It goes down the hill and then starts up the hill. it goes down the second hill, and then comes to the end of the ride. So in this case, our axis labels are time and speed. So you just kind of take a peek at them. In this one, it speeds up, stays the same, speeds up, slows down, speeds up, slows down to a stop. In graph 2, it speeds up, comes to a stop, speeds up, slows down, but doesn't come to a complete stop, speeds up, slows down, comes to a complete stop. In graph 3, it speeds up a little bit, then stops suddenly, it stays stopped for a certain period of time, then all of a sudden it goes really, really fast, and then all of a sudden it slows back down. So you guys kind of have to decide which one matches. So I kind of look at other things. One thing is that it does come to a stop for a little while. This ride never comes to a stop, or this ride never comes to a complete stop. Okay, so I think we could rule out graph 1 because it never comes to a complete stop until the very end of the ride. This ride, though, it comes down for a bigger chunk of time, probably. This one says at the top of the hill it slows down and comes to a stop. This one just really quickly comes to a stop. So there's the differences there. And then it talks about it starting up another hill. So that would be this gradual, like up, 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 up. You're going faster, 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 faster. And then it goes down the second hill and then comes to the end of the ride. And then this one is very much more abrupt. So you would be able to make the connection with graph 2. So it's kind of just being able to read and see what happens with those graphs. Okay, the last type of problem is they want you to be able to take information and then put it on a graph. So it says the table shows an altitude, that's the height of an airplane during a flight. Make a graph that shows the altitude information. So these are kind of like ordered pairs. Time is your X, and altitude is your Y. So 0, 0 is where we start, and we're just going to plot these points like we do on a regular graph. So 10 and 5,000, 20 and 10,000. And then if you need to use can use a little ruler. And then 30, oh, sorry, I should have went to 10,000. I wasn't paying attention. And then 30 and 15,000. Be over here. And then 40 and 15,000, that means the elevation didn't change. And then 50, it went back down to 10,000. And then 60 was at 5,000. And then 70 was at 0. So that means that if we were looking at the flight of this plane, it went up, and it went up, and it went up, and then it stayed at this elevation of 15,000 for a while. Was it 10 minutes? And then it came back down. So if this was your plane, it would have probably been a fairly smooth flight. Okay, so that's your lesson. You're just trying to make connections between graphs and descriptions, and then being able to plot the information on a graph.